Good morning, class. We are looking at statistics, practice test 2, module 2, covering chapters 4 and 5. Here's chapter 4, probability. Chapter 4, probability. Here's the second module. Let's start with some definitions. A simple event, a sample space. We want to define those. A simple event is an outcome or an event that cannot be further broken down into simpler components. A sample space is the set of all possible outcomes or simple events of a probability experiment. If two events are mutually exclusive, also called disjoint, the probability that both will occur is events A and B are disjoint or mutually exclusive if they cannot occur at the same time. That is, disjoint events do not overlap. In other words, symbolically, we write probability of A and B is 0 or probability of A intersection. This is the intersection symbol. A probability of A intersection B is 0. So that makes them disjoint or mutually exclusive. The probability of an event is always between 0 and 1. Probability of an event is defined as probability of A equals N of A over N of S is the probability of event A. And the probability is always between 0 and 1. Can it be 0? Yes. Can it be 1? Yes. But nothing outside the two numbers. The sum of probabilities of all final outcomes of an experiment is always 1, everybody. The sum of the probabilities of all the outcomes in a sample space is 1. Summation of P sub I must add up to 1. The sum must be 1. So these are some definitions, and to elaborate on that, let's look at rolling a die. A normal one, a common one, has 6 sides, numbers 1 through 6. So what's the sample space? The common die has 6 faces. We usually call the faces 1, 2, 3, 4, 5, 6. That would be the sample space. So simply put, every outcome is mentioned here. Every possible outcome is mentioned. That's a sample space. A simple event, any individual number such as 1 or 5 or etc. would be an example of a simple event. A compound event, an event having more than one outcome, such as, let's say, odd numbers, 1, 3, 5, and so on. So sample space, all possible outcomes. Simple event, simply one individual one. Compound, more than one. All right, the number of combination of n items selected n at a time is the number of permutation of n items selected 0 at a time is. So I want to discuss the two topics, permutations and combinations. So here's the definition, permutation. Permutation is an arrangement of objects in a specific order. Order matters. Example, the letter arrangement of ABC, okay, would be ABC, ACB, BAC, BCA, CAB, and CBA are all counted separately as 6 different permutations. So when order is important, for example, you're coming up with a code. When n different items are available and R of them are selected without replacement, the number of different permutations, order counts again, is, here's the notation we write, NPR, okay? So it's n factorial over n minus R factorial. And remember, n factorial goes with n times n minus 1, n minus 2. Combination is a grouping of objects where order does not matter. So the formula NCR is n factorial over r factorial, n minus r factorial, or you can write this one divided by r factorial. And so that's the definition. Now we're going to answer part A. So permutation and combination are defined. So CNN is n factorial over n factorial times n minus n factorial. This is, of course, 0 factorial. 0 factorial by the combination becomes 1. These two cancel each other, and the answer is 1. And again, just reminding everyone, when we write n factorial, it means n times n minus 1 times n minus 2 times all the way to 1. That's the meaning of n factorial. The number of permutation of n items selected 0 at a time, we are going to put it into this formula. Okay. So there are a couple of ways to look at it. This actually means n times n minus 1, n minus 2, all the way to n minus r plus 1. And here's the reason, because this n factorial would be all of this times n minus r factorial. They cancel each other. So in other words, the reason behind this, because then times n minus r factorial divided by n minus r factorial, they cancel each other. So let's write it for the 0, and this is what we get, n factorial over n factorial. This is also 1. So both of them end up being 1. So if you're dealing with the combination of n choose n, it becomes 1. Permutation of n choose nothing, 0 is also 1. A pizza parlor offers 10 different toppings. How many 4-topping pizzas? We mean different toppings. We're not going to repeat this. Are possible. As you can see, order is not important. Doesn't matter the first topping that you mentioned is what versus the second or the third or fourth. Okay. Pepperoni versus mushroom, or you name. So we use the combination, and n is 10 and r is 4. Now, just to let you know, of course, at this point, you can put it into a calculator, but if we write it in this manner, again, you can put it into a calculator. One way to simplify, I want to show you this. So the bottom, the 6 factorial is the closest to 10. So you're going to keep the 6 factorial in the denominator. The top, you're going to write 10, 9, 8, 7. When you stop at 6, you put it at 6 factorial. And then 4 factorial at the bottom, you have to expand it. So what happens, again, if you were to do it by hand, they cancel each other. And you know that 4 times 2 is 8. 9 and 3, 3. So 10 times 3 times 7, 200. In other words, if you were doing it by hand, it's doable. It's really not too bad. Okay, that's my point. So order is not important. Now, part D, how many 6-letter code words can be made from the 26 letters of the alphabet if no letter can be used more than once in the code word? Obviously, order is important, results in permutation, and so we're going to use the permutation formula where n is 26 and R is 6. And I hope you recognize this as, in essence, 26 times 25, 24, 23, 22, 21. There are 6 spots, okay? Or you can write this as 20 factorial. You see that the 20 factorial cancels this out. Or you put it into a calculator and you come up with the answer, okay? 165,765,600. Answer the following part. A quiz consists of 3 true-false questions. How many possible answer keys are there? Write out the sample space and tree diagram. The formula is how do you find the sample space? The size, that means N of S, this size of a sample space, is the number of outcomes per stage and being raised to the power such that the exponent is the number of stages. So N of S, as you can see, true false has only 2 outcomes. And how many questions? 3, 5, 10, whatever the number of questions would be the number of stages. To cubed, there are 8 outcomes. To understand that, okay, take a look at this one. So when you go with the tree diagram class, the top and the bottom, you want to be consistent. If the top is T standing for true and the bottom is false, then that's the first question. The second question for T, again, you keep the top as T, the bottom as F, TF. And then the third one, again, TF and so forth. So this means T, T, T. This means T, TF. This means TFT, TFF, and the rest of it. So this is stage 1 or question 1, stage 2 or question 2, stage 3 or question 3, 8 outcomes. We start with TTT and we end up with FFF. That is the sample space. Part B, the sample space for tossing 5 coins consists of how many outcomes? Write out the sample space. Again, N of S is the number of outcomes per stage. So a coin has either heads or tails, 2 outcomes. How many stages? Well, the number of coins in this case is the number of stages. So N of S is 2 to the power of 5, which is 32 outcomes. So the tree diagram, you start with H and T. If H is at top, T is at the bottom, then the second coin, again, H at top, T at the bottom. The second gives you 4 outcomes. The third gives you 2 cubed. The fourth gives you 2 to the fourth, and the final one, 2 to the fifth. So looks like this. So HT, look at this one. Then HT, look at 1, 2, 3, 4. And there's next one, and the next one, and the last one. So we start with all H's. H, 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 H. There are 5 of them. And for example, the next one would be H, 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 T. And if you go all the way down to T, all of them T's. So this is stage 1, the first coin, stage 2, the second, stage 3, the third, stage 4, the fourth, and stage 5 is the 5th coin. And it looks like that. It starts with H, 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 the top one, and it ends with the bottom one, T, 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 and everything in between. 32 outcomes. I hope everybody can write that. For example, as I said, the second one would be H, 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 T. Look at this. So that's how you do the writing. A random sample of 100 people was asked if they were for or against the tax increase on rich people. Of 60 males, 45 were in favor. And of all females, 22 were in favor. Write the contingency table and answer the following questions. If one person is selected at random, find the probability that this person favors the tax increase on rich people. So the very first thing is to come up with table. So we have total of 100. We have males, females, for and against. So we are going to do the following. This is the table, the contingency table. When we have the rows, in this case, there are really 2 rows and then the total, and columns, 2 columns and a total. So that is called a contingency table, a 2 by 2 in essence. Remember, the last one is the total. So let's start putting the numbers. The very first thing says a random sample of 100 people. So the total, the entire population that we are sample that we are dealing is 100. So this total goes here, 100. So we should be able to fill this up easily. Then we read, it says of 60 males, so male, and we're going to represent it with M, female with F, for tax increase with T, against it with A. So this is because it makes it easier to deal with it at the end. So of 60 males, so males right here, it goes 60. 45 were in favor, so for tax increase, so 45 goes in here. So we are filling up the table accordingly. And of all females, so females is this row, 22 were in favor. So 22 in favor goes here, 22. Okay. So now we can fill up the rest. Obviously, if this is 100, they should add up. So this must be 40. If this is 60, this 2 must add up. So this must be 15. 45 plus what number is that? And then you add up these 2 numbers, you get 67. If this is 67, subtract 100, the rest of them is here, which is 33. So you can figure out the rest accordingly. So first we put in the numbers given. The other ones can be easily evaluated. So this person favors the tax increase, so we want P of T, which is N of T over N of S. So in short, when you go with probability, start with the denominator first. So how many we have total? 100, N of T. T means this column, which is 67, or simply 45 plus 22. So 67 over 100. Now, you can leave it like that. You can write it as a percentage. You can write it as a decimal. It depends on how they want it. This is an exact answer. And because it's being divided by 100, 0.67 or 67% is also exact. But if it's not, and you want to go with decimal or percentage, you want to pay attention to the number of the decimal they ask you. If they don't, just keep it as a fraction, which is an exact answer. This person is a female, so P of F is N of F or N of S. These are so far basic probability or marginal probability. And so N of S is, of course, again, 100. How many females? We have 40, which is 22 plus 18, 40. And of course, you must always simplify. So 40 over 100 is the correct answer. Simplify to 2/5 or 0.4 or 40%. This person opposes tax increase on rich people given. Now, I'm going to discuss the given in a moment. That the person is a female. If this person is a female, she opposes the tax increase. This is 2 ways to write it. Please understand the written in blue means the same thing. When you have the word given, it's called a conditional probability where it has a specific formula. Probability of A given B, this is how you read this, is probability of A intersection B over probability of B. Probability of B given A, the numerator is the same, probability of A intersection B. The denominator is probability of A. That is by definition. Therefore, in this case, the probability of opposing means A, given female means F, probability of A given F. And according to this formula, is probability of A intersection F over probability of F. Now, why does it become N of A intersection F over N of F? Here's the reason. Because this one is N of A intersection F over N of S. And what about this one? It becomes N of F over N of S. So it's a complex fraction where you can drop those and you get this. So one easy way to handle this, probability of A given F, always I start with the denominator. Given F, that means you're dealing with the F group, you're dealing with the female group. That means your total sample space of 100 is no longer there. It has shrunk to what comes after the given. So total sample space now it's shrunk to 40. So your denominator is 40. And out of those 40 females, how many are opposing? So 40, you have to choose 22 or 18. And because you're choosing to go with the against, you have to go with 18 over 40. And simplify 9 over 20, 45%, 0.45. Conditional probability is known as, okay? So conditional probability. This person is a male, given that he favors the tax increase on rich people. Again, if we want to go with the easy way out, okay, the moment you see given, it's a conditional probability, and this means the probability of M given T, because favoring we said T, and that means probability of M intersection T over P of T, which becomes N. So simply put, for the T, how many do we have? Okay. For the T, we have a total of 67. So the denominator is 67. And out of those 67, how many are male? 45. So 45 over 67. Okay. So this actually comes from here, just 45 over 67. Now, I put it with 4 decimals, but this is an exact answer, and you better keep it as exact unless they ask you for the percentage or decimal. It's important to know that. We're going to continue with the same question, and we have the following part. This person is a female and favors the tax increase on rich people. So the intersection of event. So probability of F, female, intersection T, okay, remember, favors, okay, for tax increase, is N of F intersection T over N of S. And this one, in the case of a conditional probability, your sample space changes. In every other case, the sample space is total. In this case, is 100. Okay, everybody. So the denominator is 100. Now, N of F intersection T. So F means this group. And with this group, and T means this group, what's in common? 22. So 22 over 100. You can write it as 11 over 50 or 0.22 or 22%. So, and statement. Now the or statement. This person opposes the tax increase on rich people, or is a female. So here's the definition of an or union of event. Probability of A or B, or probability of A union B, is P of A plus P of B minus P of A intersection B. So in this case, person opposes, that means A, and female, that means F. So we want probability of A union F according to this. So all you have to do, change the B to F. And by the way, so you have a denominator, which is 100. N of A, how many A's? We have 33 F's, we have 40. But why are we taking A intersection F? So take a look at A group and the F group. You see this number 18 is being repeated once for females, one for against. That's why we take it out, because this has been accounted for 2 times. So minus 18. Again, 33 and 40 are obvious. Why are we taking out 18? 18 makes this one 33, makes this one 40. So it has been accounted for 2 times. We get 55 over 100, 11 over 20, or 0.50. Are the events females and opposes the tax increase on rich people? Independent. Explain. Well, recall the conditional probability for probability of A intersection B, probability of B intersection B. So if you look at this numerator, is the product of these two, is the cross product. This is elementary algebra. So if I put 1 here, or here, here's the cross product. So probability of A intersection B is probability of A given B times probability of B, or probability of B given A times probability of A. So there are 2 ways to write. Independent events. The occurrence of one event does not change the probability of the other event. Probability of A given B becomes probability of A, and probability of B given A becomes probability of B. So conditional probability becomes a simple probability or marginal probability if they are independent. So if they are independent, therefore, this probability of A intersection B becomes the probability of B times probability of A, or probability of A times probability of B. So this would be one way to define independence. So we can pick one of them. For example, probability of A given F, and check it with P of A, or probability of F given A and check it with probability of F. Now, as far as definition, it says events females and opposes the tax increase on rich people are dependent because the occurrence of one of the events does affect the occurrence of the other. But this is just a definition and it's very vague. Let's prove it. To prove it, we go with numbers. Probability of A given F, as I mentioned, this is a conditional probability, start with F, and F has total of 40, and A is this one, 18 out of 40. Again, it can be simplified. But probability of A, the denominator is 100, and how many A's is 33, 33 over 100. You don't even have to simplify it to see that they are not equal. Okay, so that doesn't work. Therefore, they are not independent, making them dependent. So, because I've seen sometimes students just write this and there is really no proof there. This is the proof with numbers. Are they mutually exclusive? Well, if they are mutually exclusive, their intersection must be 0. They are not mutually exclusive because a person can be both female and oppose the tax increase on rich people. So probability of A intersection F, here's the A, here's the F, it's 18 over 100. So because this is not 0, again, this is the definition, this is the proof with numbers, and that is extremely important. Okay. All right. Answer the following. Find the probability of getting the amount of the outcome of tails and 2 when a coin is tossed and a die is rolled. Remember, uh, heads and tails, 2 outcomes, and this one is for um, a die that is a regular one with 6 sides. So reminding that independent events means probability of A intersection B is pure probability of A times P of B. And when you are dealing with a coin and a die, they have nothing to do with each other. They are independent. So it's the probability of tails times the probability of 2. Probability of tails, as you know, is obviously it's 1 out of 2. There are 2 outcomes, tails versus heads. And this one has 6 outcomes, so 1 out of 6, right? Because you're dealing with the rolling a die. And the answer is 1 over 12. Part B, a classic counting problem is to determine the number of different ways that the letter of personnel can be arranged. Find that number. All right. Permutations rule. Distinguishable permutations. When some items are identical to others, as you can see here, for example, n repeats, just for the sake of argument. So how do we do that? The number of different permutations or order counts when n items are available and all n of them are selected without replacement, but some of the items are identical to others, as it happens here. Is found as follows: n1 are alike, n2 are alike, and all the way to the end. We write n factorial over n1 factorial times n2 factorial all the way times n sub k factorial. So in this case, we have n 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. And we're going to write, for example, P, we have only one of them. E, we have 1 and 2. R, we have one of them. S, we have one of them. O, we have one of them. N, we have 2, and L, we have 1. So we write that. Now, so it's 9 factorial over all of this. Most of them are 1 factorial, so they don't make any difference. But what matters is that this is 2 factorial and this is 2 factorial. So we're going to write it as 9 factorial. In order not to make a mistake, even we write all those ones. Okay, 1 factorial for P, 2 factorial for E, and all the way to the end. The last one is 1. The one before that is 2 factorial. You can put it into a calculator, simplify it, whatever is 90,720 ways of arrangements. A box consists of 14 red and 36 blue markers. If we select 3 different markers randomly, what is the probability that they are all red with replacement? Well, probability of red is n of red over n of s. Clearly, R represents the red, and S is always the sample space. So how many reds? 14. How many total? 14 plus 36. You do the math, and you end up with 0.28, 14 over 50, 7 over 25. And that would be when we pick 1 red. Now, if you want 3 of those, that means P of R1 intersection R2 intersection R3. Because we are doing it with replacement, they become independent. Because when you do it with independent, when you put them all back, all 14 reds and all 36 blue are back. So nothing has changed. So that means the probability of each one is 0.28 or 7 over 25, and then to the 3rd power. So probability of 3 red is probability of 1 red to the 3rd power. You put it into a calculator. and you get 0.021952. What is the probability that they are all red without replacement? Draw a tree. However, even if this is not mentioned, and there's A and B, there's only one part, it is always without replacement. Think about it. Yeah, 14 red and 36 blue markers. We select 3 different markers randomly, and that's all. And we don't mention with or without replacement. It means without replacement. Okay, nobody's going to replace it and then pick another one. Okay, so now things are more interesting. Probability of 3 red is probability of R1 times probability of R2 given R1 times probability of R3 given R1 intersection R2. Normally, not a lot of people write it in this manner, but the idea is exactly what you see here, which means what is the probability that the first one is red? 14 out of 50. Let's go back here. And I'm going to keep it as 14 out of 50. Now, what is the next one being red? Now, I hope you recognize this, that one red is gone. So we have 13 left. And now total is 49, 13 out of 49. And the third one more red is gone. So 14 goes down to 13, now goes to 12. And the denominator of 50 goes down to 49 and now 48. So we write it in this manner. Probability of 3 red without replacement. And again, even if they don't mention it, that's what it means. 14 over 50, 13 over 49, 12 over 48. The product is the answer. You come up with the exact answer here, or 0.0186. Okay. Now, as far as the second method, probability of all red, combination of 14 choose 3, because we have 14 red, over combination of 50 choose 3. That would be using combination in this manner. Okay. Now, to be honest with you, we really have to, the reason I want to write this, or probability of 14 3 times probability of 36 0 is combination of 50 over 3, 50 given 3, because the question may be instead of all red, let's say we want 2 to be red and 1 to be blue. So you make this one 2 and you make this one 1. Because we are picking 3, everybody, these two numbers must add up to 3. And because the total is 36 plus 14, these two numbers must add up to 50. If we were to do it by a tree diagram, take a look. The first red, 14 out of 50. The first blue is 36 out of 50. That's the first stage. The second stage, we no longer have 50. All of them have the denominator 49. Red goes down to 13, but the blue doesn't change. Over here, because we are in the blue branch, the red doesn't change, it remains as 14, but the blue goes down from 36 to 35. And you can figure out the last column in the same manner. So this is red, this is red, this is red. So first of all denominators are 48. Secondly, red, 14, 13, 12. Take a look. But the blue is 36. If you look at the top branch, you can figure out the rest. For example, the last one, okay, the blue 36, 35, and now it's 34. So you should be able to figure this out. It's extremely important to understand the concept. If the probability of winning the race is 5 over 12, what is the probability of losing the race? Well, let's say P of W, W standing for the winning, is 5 over 12. That is given. Now, what is the probability of losing? The complementary event, probability of A bar or A naught complementary event is 1 minus P of A. So probability of losing is 1 minus the probability of winning. 1 minus 5 over 12 is obviously 7 over 12. So that's elementary, very straightforward. Remember, the total probability is always 1. What are odds against winning? We want to discuss the odds, everybody. So what are odds? Well, the actual odds against event A, we write O. Against that, we're going to use A bar or A naught or complementary event. By definition, is probability of A naught over probability of A, expressed as form of A to B, A colon B, or A to B. A and B are integers. So odds against winning, according to this definition, must be odd against winning, or odds for the losing must be probability of losing over probability of winning, according to this definition. And that's the definition. Probability of losing is 7 over 12, winning is 5 over 12, and that's a complex fraction. You can drop the denominator, you get 7 over 5, or you can write it 7 to 5. If the payoff odds is listed as 6 to 1, how much profit do you make if you bet $10 and you win? So what is payoff odds? The payoff odds against event A is defined as follows. Payoff odds against event A is net profit, okay, to the amount of bet. So net profit divided by the amount of bet. So what is net profit? Do the cross product. This times this. So net profit is payoff odds against event A times the amount of bet. In this case, the payoff odd is 6 to 1. That means this number. If it's 6, let's say to, I don't know, 4, you have to change it to 6/4. So you have a fraction of 6 to 1, which simply means 6 times 10, and it's $60. When two different people are randomly selected from those, let's say, in your class, find the indicated probability. Assume birthdays occur on the same day of the week with equal frequencies. There are two questions. Probability that two people are born on the same day of the week versus probability that two people are both on, doesn't matter, Monday, Tuesday, Wednesday, pick one day of the week. And I want to discuss the difference between the two. This one says same day. This one say one day. Again, change the Monday to Tuesday or Wednesday or Thursday makes no difference. You get the same probability. The concept is the same. So what happens in the first case, no particular day is specified. The first person can be born on any day. And the second one, to be born on the same day, has a probability of 1 out of 7. So probability of the second person born on the same day is 1 over 7. And therefore, the probability for both persons born on the same day is 7 over 7 times 1 over 7. 7 over 7 or simply 1, so it becomes 1 over 7. What is the difference between on the same day and on Monday? You are specifying which day, specifically Monday or specifically Tuesday. Each person has a probability of 1 over 7. So probability that the first person is Born on Monday is 1/7. So the same thing is for the second person. So both of them born on Monday would be 1/7 times 1/7, which is 1/49. Okay. How many different auto license plates are possible if the plate has two letters followed by four numbers? First of all, there are 6 spots. Let's go with 1, 2, 3, 4, 5, 6. Okay. So we want two letters. So we want 26 and 26. Four numbers, 10, because there is no restriction. So you have 26 times 26 or 26 squared, 10 times itself 4 times. That means 10 to the power of 4. And whatever the answer is simple. Okay. Can put it into a calculator. But the bottom line is, how do we arrive at the answer? That's my point. And I hope everybody's following that. Okay. Now we have three letters, no repeat, followed by three numbers. Repetition is okay. So three letters, we have 26, and then 25, and then 24, because we can't repeat it, and we're done. Then the numbers, no restriction, 10, 10, 10. So 26 times 25 times 24 times 10 cubed. And we have four letters. Repetition is okay, followed by two numbers. So again, we have those 6 spots, everybody. So four letters, that means 26 can be repeated. How many times? 1, 2, 3, 4 times. And then two numbers, no repeat, 10 times 9. So 26 to the power of 4, 26, 26, 26, 26. This one is 10. But since it can't repeat, has to go down to 9. And that's important to understand, everybody. Four places. So this is 4 spots. Each character is either a letter or a number, alphanumeric. We have 26 letters, we have 10 digits, they add up to a total of 36. There is no restriction, each one can be 36. So 36 to the power of. Again, you put it into a calculator and you figure it out. It's not a big deal, everybody. In a first grade school class, there are 10 girls and 8 boys. In how many ways can the student finish first, second, and third in a foot race? Assume no ties. Well, order is important, which makes it a permutation. And we have PNR, and total of 10 and 8, 18 kids. First, second, and third, choose 3. Or you can say 18 times 17 times 16, which is, if you go with the calculator, you enter the value of n, then press math, then select poverty, then select the factorial. Okay, and enter. For permutation, you go with NPR and NCR. This is for factorial. It's for the permutation, and you get this number and you put it there. The girls finish first and second in a geography contest. So we are just dealing with 10. Okay. And again, order is important. But now we are not dealing with the total of 18 kids, but only 10 girls. So permutation of 10, choose 2. Simply means 10 times 9 or 90. Three boys selected for lunch, and of course, order is not important because we just said three. From which group? From this group. So N is 8, R is 3, order is not important, becomes a combination C, N, R, combination of 8, choose 3. If we were to write it 8 factorial over 3 factorial times 5 factorial, it becomes 56. Okay, or you can use a calculator for that. Again, it's very straightforward, everybody. I hope nobody has any problem with that. It's we've discussed that already, and I think everybody's fine with that. In any event, now what happens is we want 6 students for a team. Doesn't matter what kind of a team, hockey team in this case. So from 18, we want to choose 6. Order, of course, is not important, makes it a combination. Combination of N, R, N is 18, and R is 6. So we can write that as 18 factorial, 6 factorial times 12 factorial, and you can write 18 NCR6, and it gives you the answer, and you're done. Again, if you can use a calculator. It's really not a big deal, everybody. But the fact of the matter is you really have to recognize which one you're using and why, meaning is it a permutation, is it a combination, and why. As long as you recognize that, you're in good shape. We want 5 students, 3 boys and 2 girls. So 3 from this, 3 boys, 3 from this group, combination of 8, choose 3, and 2 from this group, combination of 10, choose 2, okay? Because order is not important. So combination of 8, choose 3, combination of 10, choose 2, and it's the product of the two according to this. This one would be 8 factorial over 3 factorial times 5 factorial. This would be 10 factorial over 2 times 2 factorial times 8 factorial. You put it into calculator, you come up with the answer. Again, this is what really matters, understanding what we do and why we do it this way, okay? That's really important to understand why we go with the combination. We want 4 gears for a field trip. Obviously, order is not important, and N is just 10. So combination of N, choose R. N is 10, R is 4. Order is not important. Combination of 10, choose 4, 10 factorial over 4 factorial times 6 factorial, or you put it in the calculator, you get 210. Very straightforward, everybody. In a lottery game, a player picks 5 numbers from 1 to 48. If 4 of the 5 numbers match those drawn, the player wins second prize. What is the probability of winning this prize? Now, it's important to start with the formula. The probability of winning is N of winning over N of S. I believe when I want to go with the probability, if possible, I want to come up with the denominator first. So that would be always my choice. So what is N of S? N of S would be N of pick 5 numbers from 48. Order is not important. So 48, choose 5. It's a simple combination. Order is not important because we are choosing 5 numbers. Let's put it in. So that would be N of S. Now, n of winning, we want 4 of the 5 numbers. So we want 4 to be correct and 1 to be incorrect. So n of W, meaning winning, is n of 4 being correct, 1 being incorrect. Order is not important according to this. So n of winning is combination of 5, choose 4, because there are only 5 possibilities to get it correct. And what is left from 48? 48 minus 5, 43. From 43, you can pick one incorrect one. Put it in. So this becomes the numerator 5C4 times 43C1, and n of s is 48C5. Now, can put it into a calculator, do the math. It's not important. What matters is that understanding this one, how we arrive at the numerator, how we arrive at the denominator, put it into a calculator, simplify it. This is an exact answer, everybody. It's important to know this is the exact answer, and you should be able to come up with the exact answer and simplify it accordingly. If they want a decimal, they will ask you for how many, okay? And you want to basically follow that. A similar question. A poker hand consisting of 5 cards is dealt from a standard deck of 52 cards. Find the probability that the hand contains exactly 2 face cards. Well, again, the same thing. We want the probability of 2 face cards. So we want probability of 2F. F stands for the face cards. N of 2F over N of S. We write that. And I like to start with N of S, as I mentioned, always. So I want 5 cards. From how many? 52. That is combination. N of pick 5 cards from 52, order is not important. So you put it into a formula. N of S is 52 combination of 5, which means 52 factorial over 5 factorial times 52 minus 5 factorial. Now, the denominator is N of 2 face, which means you can choose 2 face cards and 3 non-face cards. Order is not important. So what are the face cards? Reminding you of the king, queen, and that gives us 3. So if there are a total of 3 per suit, and we have 4 different suits, then we have 4 times 3, 12 face cards, minus 52, the rest of them non-face are 40. Which means for n of 2 faces for the numerator, we're gonna choose 2 from those 12, 3 from those 40. Okay. So let's put it in. So this goes to the numerator, this goes to the denominator. Again, you can put it into a calculator just for the sake of argument. This number is 66, this number is 9880, this number is, what do we have here? 3 and 3, 2,005,980, 598,960. And you do the simplification, and you end up with this exact number, 209 over 830. And here's the last question, class. A factory received shipment of 16 sprocket, and the vendor who sold the items knows there are 7 sprockets in the shipment that are defective. Before the receiving foreman accepts the delivery, he samples the shipment, and if too many of the sprockets in the sample are defective, he will refuse the shipment. So part A. If a sample of 7 sprockets is selected, find the probability that all in the sample are defective. So that's part A. Well, again, probability. Probability of all defective is N of all defective over N of S. Again, N of S, we have how many total? 16. How many are we picking? 7. So N of S would be combination of 16 choose 7. That would be the denominator. What about all defective? Well, we're going to choose 7 from the 7 and the rest from the rest. Remember, 16 minus 7 is the rest of them that are non-defective. 16 minus 7 is 9. So we're going to choose 7 from 7 and 0 from 9. In other words, N of all defective would be C7, 7, C9, 0. And by the way, it so happened if you calculate this one is 1, this one is 1, each one is 1. Okay. Because there's only one way that all of them are defective. Okay, that's really the reason in essence. So you write this in the numerator, you write this in the denominator. And if you use a calculator for the denominator, because this one, as I mentioned, each one is 1. So you get 1 out of 1,000, 11,440. Second method, there are 7 spots. So again, all in the sample are defective. So 7 out of 16 would be the first spot. When we go to the second one, remember 1 is gone. That means the denominator from 16 goes to 15, and out of 7, now we have 6 left. So 7 over 16, 6 over 15, 5 over 14, 4 over 13, and all the way to 1 over 10. And if you go this route, you get to the same answer. So that's another way of coming up with the same answer. Part B, if a sample of 7 sprocket is selected, just like that, find the probability that none in the sample are defective, which means, again, we have the same N of S, everybody, the same N of S, but this one, if you look at this one, combination of 7 choose 0, N of 7 choose 0, right? Because we don't want any defective, but 9, we want to choose how many? 7. So N of non-defective over N of S. N of S is already discussed, and it makes a perfect sense. And this one, 7, 0, 9, 7. And if we put it into a calculator, 9 and 7, the combination gives us 36. This one is 1, everybody. And the denominator is as before. So it's the ratio of those, which becomes 9 over 2860 precisely. Now, the second method is that you want to sample, find the probability that none is defective. So if there are 7 defects, then 16 minus 7, 9 of them are not. So 9 out of 16 would be the first choice. Then it goes down to 8 to 15, 7 over 14, and so on, giving you exactly the same answer as this.